Imagine you need to clean up a very dirty floor after a house renovation. You walk into a hardware store and ask the clerk for something strong enough to get the mortar off the tiles. The clerk reaches under the counter and hands you a heavy plastic gallon jug. Right on the front, the label reads Acido Muriático. Now, if you took that exact same liquid and set it on a bench in a professional chemistry lab, the bottle would have a different label, Ácido Clorhídrico. That scientific name carries a specific logic. It functions as a universal map, telling you exactly which elements are reactive inside the bottle before you even open it. Once you understand how to read this code, you can hear any acid's name and immediately visualize the exact chemical elements floating inside the jug. Let's start with the simplest group, the hydracidos. These are acids that contain absolutely zero oxygen in their composition. The naming formula is straightforward. You take the word ácido, add the name of the main element, and attach the ending hídrico. Take a hydrogen atom and attach it to chlorine. We get ácido clorhídrico. Swap the chlorine for fluorine, the name becomes ácido fluorhídrico. Use sulfur, we build ácido sulfídrico. If you've smelled rotten eggs, you know this chemical. The sound hídrico is a guarantee. The moment you hear it, you know there is no oxygen inside that molecule. Next, we have the oxyacidos. Because these molecules do contain oxygen, the naming code requires a bit more detail. A single element can often form two different oxygen-based acids, one with a higher amount of oxygen atoms and another with fewer. We distinguish them by the suffix. Use eco for the version with more oxygen and oso for the one with less. This comparison shows the difference. On the left, sulfur holds 4 oxygens. It is ácido sulfúrico. On the right, holding 3, it is ácido sulfuroso. Nitrogen follows the same pattern. 3 oxygens give us ácido nítrico, while 2 create ácido nitroso. You can remember this by looking at the length of the suffix. The word eco is larger than oso, and the larger word carries the higher oxygen count. When an element only forms one common oxygen-based acid, we default to the eco suffix. That is why the gas in your carbonated soda is called ácido carbónico. By simply listening for the suffix, you can instantly identify the oxygen hierarchy of the chemicals you interact with. These naming rules apply to chemicals that power your world every day, often in places you wouldn't expect. Ácido sulfúrico is the liquid inside your car battery. Its corrosive power is incredibly high. If a single drop hits a spoonful of sugar, the reaction instantly boils the white crystals into a black mass of pure carbon. Never, ever attempt to open a battery. You know ácido clorhídrico as the muriatic from the hardware store, but your own stomach manufactures it constantly to digest your food. Ácido nítrico is a cornerstone of agriculture. Corn crops across the country grow thanks to nitrogen-based fertilizers derived from this acid. Finally, there is ácido fluorhídrico. It is the unusual member of the family that can actually corrode glass, which is why glassworkers use it for etching and why it must be stored in plastic bottles. From the engine of your car to the soil in the fields, these acids are actively shaping your daily routine. Next time you stand in a hardware store aisle, the labels look different. You are no longer reading generic brand names. You are reading the chemical ingredients through a decoder ring. Hídrico signals 0 oxygen. Ico and oso signal its presence, with the ico version holding the higher concentration. Mastering this code pays off in our next topic, where these specific acid names become the foundation for naming chemical salts. Before we build those salts, however, we have to meet the acid's natural opposite. There is an entire family of chemicals designed to reverse everything an acid does. In our next class, we will identify this rival group, the bases. We'll explore the chemistry of the soda caustica in your drain and the white cow on the garden wall.